turn everything over to Shawn from WVU and the Energy Land Management Program.
All right, thanks, Johnny. Hopefully everyone can hear and see. Everybody sees the screen share at this point. So I think you originally asked me this maybe as far as last fall, I think, and so it's a pleasure to be on with you guys and have a chance to kind of go over the ELM program at WVU, and also to discuss some of the research that we have related to right-of-way management and development. So it's kind of interesting. We have a lot of research projects going on, which people don't always realize are associated with these programs. And fortunately, right now we have a number of projects that are centered around right-of-way. So at this point, we'll go ahead and see if I can make this work. I apologize if I'm not looking. I've got multiple screens, so if I'm not looking at you, I apologize. I can't see where I'm looking at this point. So the program, if you're not aware, was originally initiated in 2015, and I got to put my phone on not disturb. In 2015, that was when we originally started. We had been offering classes. I had started offering classes as far back as 2013, but we became official through the Board of Governors at WVU in 2015. The program is 120 credit hours across 3 colleges at this point. It used to be across 4, but at this point we're across 3. The Davis College of Agricultural and Natural Resources, the Eberly College of Arts and Sciences, and the Chambers College of Business. If we look at our enrollment, and I just wanted to go over the program quickly before we get into the research. So just to give you a breakdown, if we look at enrollment, on the left is 2019. On the right is 2018. So you can see a total of about 115 students last year. This was up from, and I have this backwards. You see that now. So the actual graph is, on the left is 2018, we had 115 students. On the one on the right is actually 2019, 107. So a little bit of drop, but not significant. We average around 100 to 125 students in our program. The most we had was in October of 2017 with 131 students. Kind of interesting thing you'll notice is since we began in 2014, really the oil and gas industry has been in the crapper for that whole time period. Obviously with some ebbs and flows within it, but realistically, since we've started, not been the greatest. But our program is done really well. We are still currently of the 12 or 13 undergraduate programs that are accredited by the AAPL. We are the second largest. And I would say if we continue our enrollment trend with what's going on in Texas and Oklahoma, that we could be battling for one of the largest programs in the nation. And a lot of that has to do with the students and the diversity of positions that they're looking at this point. Aptitude-wise, the students are very, very well. Like this year, we've started to gather a lot more students from the Honors College. We're up to 4 students that are honors, and these are freshmen and sophomore that were just admitted to WVU in the Honors College, which is really nice for us to have. We did have AAPL Student of the Year finalists both in 2018 and 2019. I'm hoping that at one point we can, win that Student of the Year. Our academic average, our students 107 to 115 students. The average GPA is a 3.0, and that's it's awesome. Should you realize that there's no GPA cutoff to get into this program, so I've let people transfer into the program with a 1.5 GPA. And a lot of those students have turned around and I've got great jobs now and have opened up pipelines for us. So it's not, that 3.0, it's a cool metric that we're at. A lot of the other programs in the nation, you don't even start the program until your junior year, and you have to have a 3.0 GPA to be admitted into it. Whereas ours, you start as a freshman and matriculate your way through. Currently, as far as 2019, where are we pulling our students from? The majority from West Virginia. And then follow behind that Pennsylvania and Virginia is where we get most of our students. Also out of Maryland, and this ebbs and flows as well. Some years we have high Ohio numbers, and New Jersey. Just currently we've been on a downward trend there. We have pulled students from Texas and Oklahoma and Louisiana, so we've had pretty far reach at this point in our program. Part of the requirements of the ELM degree is to have an internship, and we really try to help students with this. We really work hard to get as many companies involved as we possibly can to get them this internship experience. It's our hope that, well, in the past, it was always our hope that we'd start a student with an internship and as a freshman, and between their freshman and sophomore, to get a different internship the whole way through. Recently, though, a lot of employers are wanting to hire students for internships that have no experience, so they can kind of, I guess they figure mold them on their own, and which has been hurting some of our students that have worked, they've been real go-getters and go out and get internships their freshman year on. So, both ways. So this year we are, actually about the same. We have a little over 21 students again this year that have actual internship positions that are in our class. So this doesn't count all students. This is just those that are signed up for the credits. So it's actually been a pretty good year as far as internships, even though things are down. Now, a lot of these students are working outside of the oil and gas industry. We do have some in that are working for transmission, also midstream companies. We have a lot that have moved into solar. We have quite a few kids that are in Florida right now working on solar projects, Virginia, even in some kids that were down in the Houston and Fort Worth area, but they're not down there yet. They're still working on their internship remotely. So hopefully they'll get down there soon. Real quick about the coursework and the degree, they have to take what are called the foundational courses. We require as part of this foundation a few of those, and that is the geologies. They have to make through all their geology as their science because this is a BS degree. They're required to take college algebra and statistics. They take a course called energy geology. They must take a policy course and a computer science course as part of those 54 hours. And then they take 18 hours of natural resource elective. This is basically up to the students, so 6 courses, and they can take anything here. If a student's interested in more of the surface side, they might take a bunch of reclamation courses, or if they're interested in maybe wildlife on that side, they might take more courses in this area. They could take policy.
So what's new, Maria? Not much. No, I haven't seen you in a long time.
Yeah.
You got one there. You need to mute.
Yeah, we need everybody to please mute their microphone, please.
That's me.
Okay. So it's up to the student to take as many, what courses they'd like in this area. And I'll pretty much allow anything as long as it has a natural resource sort of bent. Kids could take anything from a GIS courses through to a wildlife management. So it's up to them. And then they have to take 15 credit hours in business. Basically, all the students get a minor in business. We've worked out a pretty good program with the business school, and they're able to go through and do this. And basically, they take a basic econ and accounting, and then they have to take everything from marketing, supply chain management, ethics, finance, and business legal course. So they get a pretty good business perspective from this. They can also take Davis College, which was an agribusiness minor. I'd say 99.9% of our students take the Chambers College business minor. And then finally, they have their energy land management courses. This ranges, and like I said, they start their freshman year and go all the way through their capstone, which is their final course of their senior year. And you can see some of the courses here at freshman level, the intro to ELM. Their sophomore year, their 200 levels principles, so they're going to learn the basics here. They're going to do a lot of land and title work just starting. Their Energy Land Management 220 is kind of their engineering course. They go into ethics and negotiations, then a land and lease analysis course that's new just over the last few years. We've partnered with a Pandel software company that provides a lease analysis program, and that's been really helpful for the students to get that sort of leased land admin experience. We have 2 contracts classes, contracts 1 and contracts 2. We have added a midstream course now, a GIS course, and of course their capstone and intern. So we've really, have a lot of courses in this area, some, 25 to 33 hours, and have new courses in the planning stages at this point to kind of focus on some of the alternative, career paths that a lot of our students are going into, and include, the midstream side, but also a huge focus on renewable. I just had 2 of my students this morning got offered in Virginia to go work on a solar project there. They're excited. They're heading, just graduated and heading to Virginia to work on that project. So I really feel that WVU's niche is going to be to kind of focus on everything outside the box, while still keeping a traditional natural gas and oil and coal sort of background, but to really focus on some of the other things. So that's where we hope to go. So Johnny, kind of then I'll go into the research side. You're going to hold questions for the end, or?
If somebody has a question, they can throw it up in the chat and Brian will read it off.
All right. So I will continue on and kind of talk about some of the research, if I can get this going right. So I'm going to talk about some of the research focus. As part, most of you think that, the faculty member at the university, all we do is sit around and pontificate about our naval, or, you don't do anything. Most of my friends call me and say, what do you actually do, right? So, the teaching and, building these students up from the freshman year on and getting them jobs and keeping in track, that's one part of it. But the other side, part of my position has, three legs of the stool. One's teaching, one's service, and the final is research. So the research component is a huge part of what we do. And, with the Energy Land Management program, we don't have a dedicated MS degree. We do have what's called a Master's in Energy Environments, which I run some graduate students through, but it is a significant part of our what we do, and it actually helps engage our undergraduate students as part of this. So I wanted to kind of go over some of the ones that we're dealing with, and I have a number of people here. We'll talk about everybody, but there are a lot of folks involved in these research projects that I'm working on, and so I just wanted to recognize some of them. So some of the projects that we have right now that are related, one of the first ones is wildlife use of pipeline right-of-ways. This is funded in partly, and I'm going to mention some of the funding streams so you guys understand. This was partly funded by the Rough Grouse Society through foundational support, and also through some larger foundations like the Mellon Foundation, and also what's called McIntyre Stennis, which is a federal pot of money that comes to the university to do the land grant mission. And so, which is really cool that we've, with the start of the ELM program, these McIntyre Stennis funds have never gone into sort of this energy work before at WVU. So with our program, we're able to funnel some of those dollars in. The second one is pipeline development metrics associated, and it's kind of an offshoot of the first one, and this is mainly funded by dollars that I have from our ELM program. And the third is this, unmanned aerial vehicles for pipeline inspection, monitoring, and landscape analysis. And this is funded by the U.S. Department of Transportation. So, we routinely are writing proposals and trying to pull together funding opportunities for projects. A lot of the stuff that's outside of the right-of-way area, we've gotten funding from a number of large companies that have, have had identified problems in their development. We've done research and collaboration with them. So I just throw that out there. There's always that opportunity to Two, if there's some things that you guys are working on, you can always collaborate with the institutions around the region to kind of get that expertise.
Hey, Shawn.
So
What
the
is
first one
UOP
is this
stand for?
wildlife use of pipelines. Basically, what's going on here, and it really went back to some of the new reclamation strategies. We wanted to understand the variation in wildlife use. And some of the things we're looking at, like how does wildlife use change from time since reclamation, varying widths of the pipeline and construction zones, what reclamation methods are used, and also the types of vegetation structure that are managed on these. Like I said, it was, they're mainly interested in the rough grouse. If anybody pays attention to this, rough grouse numbers are really down in the eastern U.S. A lot of folks are very passionate about the rough grouse. And we saw as an opportunity that, we should be doing more on some of this midstream development because they're a great habitat potentially for rough grouse and wild turkeys. So we're also working on pollinators and reptiles and amphibians, some areas that, now none of these are my expertise. But I'm, work with my graduate student on this. He's a wildlife graduate student, and we have a couple of wildlife faculty members that are working on this. So part of it, the study location is in north central Pennsylvania. I had the graduate student work through an area up there in a four-county region. And basically, because there's no good data sets of midstream infrastructure, he went through and mapped all of the new pipeline development through that period from about 2007, 2008 on, basically through a period of heads-up digitizing. It covered about 5,000, over almost 6,000 wells and 2,500 kilometers of pipeline, right? So once doing this, we worked with, focused on a few different areas that they've been doing a lot of habitat work on these midstream sections. One was Teodotin State Forest, and the other was Pennsylvania Game Commission's 12 in that area. Let's see. Some of those, why we chose those different areas, because there have been a number of different alternative reclamation strategies done on them, and we're kind of comparing those to just a traditional reclamation, one of which in the upper left corner you can see the addition of these large rock piles along the side of the pipelines to encourage some reptiles, some that you may be fond of and some that you may not be fond of. The right one there is a warm season grass development, a native warm season grass development, probably switchgrass on the pipeline corridor. The lower left is a pollinator mix that was placed on one of them, and the lower right is one up in the elk country, and they had done some work with some native forbs, and they had some exclosures on there. So all kinds of different ways, alternatives to look at different wildlife use of these areas. So that's why we chose that area, and then definitely because of the rough grouse stronghold that's still apparent in that region. Unfortunately, the graduate student went through last summer, and I believe only during what we do is actually called flush counts, where they set up these random transects along, the right-of-ways at varying distance from the right-of-ways and walk those and try to do these flush counts. They only flushed 3 grouse in, probably 500 miles of walking. It doesn't look the greatest. Did encounter a number of turkey broods and other wildlife walking these transects. Right, so for the game bird side, continuing, actually he's up there in north central Pennsylvania right now doing, continuing on his flush counts on that. He's also working with pollinators. They have there's not only looking at pollinators, but measurement of the veg structure and flowering plants. Walking these transects again over a 2-year period, there's actually a methodology that's been created to do this. They photograph all the bees, flies, butterflies out there. They do different alternating directions throughout the year. What they found so far, they found that butterflies at 79 out of 80 sites, so that's pretty cool. A low of 1 to 11 different species on the site. And the age of the pipeline, which makes sense, right? The longer it's been in reclaimed, that's the best predictor of abundance outside of physical characteristics, which you'd think of like, slope or aspect or width or those sort of things. The age was the best predictor. So kind of cool, I thought, would show some of the most common. Is anybody I don't know that because of our audio problems. I don't know if I should ask these, but does anybody recognize a pollinator there that they know the name of? This is how we figure out if people are paying attention too.
Got a monarch.
Yes, there's a monarch in the upper right, right? So there's on the left, and I don't know these either, so the graduate students helping me with these. The left is a cabbage white. The center is what's called a tiger swallowtail, the monarch. The lower left is a species of a sulfur, and the lower right is skipper. So pretty cool to see all this. This student going through there and looking at the changes in these abundance and diversity of pollinators, depending on how the right-of-ways are reclaimed. So the reptiles, amphibians, this is kind of an interesting too. If you're not familiar with this area, I had to procure like all kinds of lumber last year from sawmills in the region, which then the graduate student hauled up to a small community college in north central PA over several trips, and it cut these small boards, which are called cover boards, out of the bigger boards, and then take those out and place them on the right-of-ways, right, last summer. So it placed these in the center of right-of-ways, on the edges of right-of-ways, out in the woods or fields along the sides, all in these different areas. And remember, all the different right-of-ways have different ages, different reclamation types, and he placed thousands of these boards. So his job this summer is to go out there and to very carefully lift those boards up to see what kind of critters are underneath them. And so he started that right now. Not something that I want to be doing in north central Pennsylvania on my own or far northern Pennsylvania, but that's what they're into. So it's kind of cool what they're finding. There's been a lot of work done on these right-of-ways and how they are barriers to amphibians, especially salamanders, which are one of the biggest biodiverse or biomass. If you look at biomass of wildlife, salamanders make up the most, and a lot of people, against energy development, a lot of times those critters are, the ones they cite that you're creating these barriers for them to intersperse and to breed perhaps. And his original checks up there is finding a lot of these amphibians in the center of these right-of-ways. So which is kind of cool result at this point. Again, he'll be up there again this summer. We'll get a lot of data from the summer on those reptiles and amphibians. So if we move on, the second one, and it kind of led from that first one, Sam Nopka, the graduate student, again on this, a great student out of a college. He got his undergraduate at a private school in New York, but he's down at WVU. When we were doing the original work, which I showed you, the 5,000 wells and 2,500 kilometers of pipeline up in that north central PA, as he was doing that original work and we were working closely together, I said, hey, this is really interesting data. And the fact that we don't really know, does this pattern of development between unconventional oil and gas and midstream development, is it the same over all the regions of the Appalachians, or is this, depend on the infrastructure that's in place already? Like, what drives this development? So we did that. We decided that he had a little time during the winter, and we wanted to really look at this. So he started collecting data, and we hired a couple of our undergraduate students in the land program to do a lot of this GIS work. So what we wanted to do is map pipeline and pipeline right-of-ways in highly developed, spatially diverse areas of the Appalachian Basin. So we have the larger area in north central Pennsylvania, right? It's bigger because that's the area we're working on the RGS and the pollinators and amphibians, right? And then we chose some other areas to look at the patterns of development. We have Greene County, PA, Doddridge County, West Virginia, and Belmont County, Ohio, right? So the basic, I'm not going to go into all the results, but basically we have all of the well data for those counties, those that actually have been in place and dirt was moved on the pad. And then we acquired what's called the Nape Imagery, which is pretty high resolution aerial imagery that's done by the Farm Service that's in these areas, usually on a 2-year schedule. And we looked at these from 2007 to 2018. So tried to look at overlaying every year the wells that came on and the pipeline infrastructure within a county, and to map those new corridors that we could find. And basically, we could figure out as the wells came on what new pipelines were being developed and where they're located. So you kind of have both a total footage by well and also a timeline by well. Right, so that's what we were kind of interested to see and how it looked between those various locations. So some of our preliminary results. We were originally going to give this at a meeting this spring, but obviously it was postponed in Charleston. So we pulled together some of the data, so we can look at what we had as far as what was mapped. Kilometers of pipeline in each of these counties. The 4-county region would be the largest because it was the largest area, then followed by Greene and Doddridge and Belmont County, Ohio. You can see the wells by pad. This is kind of interesting metric as well. You can see Doddridge, the development's been going on there. Doddridge and Greene for a little while longer, more wells per pad in those areas, which makes sense. And then we can look at the pipelines in kilometers per pad, right? So how many kilometers do we have per pad? So, and it varies between the north central PA region. We were at about 0.4 kilometers per pad to Doddridge and Belmont County at 1 kilometers per pad. So you can see there on the right, which makes perfect sense. So a lot of times, obviously it's like Captain Obvious, like, as the pipelines come in, there's going to be more disturbance or more developed by for each well until you get more and more wells that are going to take up that infrastructure, that capacity. So, and our data actually show that. So it's kind of a check, even though it's Captain Obvious. It's kind of a check for our data and to see that we actually see this change. So, as more and more wells come on, the actual amount of kilometers per well decreases to a value that's somewhere around that 1 or 0.8 kilometers per pad. So for future, part of this is to look at future development, and can we estimate what those infrastructure needs are going to be for some of the development. And so finally, one of the more interesting projects I think that we've just started up is this Unmanned Aerial Systems. Again, this was funded by the U.S. Department of Transportation this year. Really cool project. We've gotten a lot of assistance from companies that working with us, wanting us to work with them on their right-of-ways. It's been a little bit difficult navigating some of the legal aspects and getting that sort of permission, but we have secured with several companies now that ability to go out there and do some of our work. So the basic of this is we want to do a real quick and dirty and look at of the technology that's available now. What's the most cost-effective combination of these sensors that we can use on these unmanned systems for monitoring pipeline conditions? And for this project to the USDOT, we were primarily interested in erosion and sedimentation, slip slides, and revegetation. And part of this is to kind of work with people that are walking these, especially after these large rainfall events that we got to monitor, large distances of these lines and have them be able to do this remotely or from certain areas, and just to see what the cost effectiveness is, right? How does it compare? So we're flying multiple of these drone systems with the following sensors. We have high-res true color, the RGB. We're able to create less than 1 meter ortho photos, like half meter. You can see this picture on the right is one of we've been working with a cooperator on a well pad site. We were doing some E&S work with a cooperator, and you can see the person sitting on the tailgate of the white truck may or may not be me sitting on the tailgate. So typically I'm working. The graduate students are working there, though, you can see. We also have this high-resolution near-infrared spectrometer on board as well. We have several different LiDAR systems. The one that we're working with now is with a company in West Virginia Red Hat LiDAR. Produces an incredible product, and I'll show you some of that here in the near future. I'm getting thousands of hits per square meter from the LiDAR, so the resolution that you can get is incredible, but a lot of data too. We also have thermal cameras on them and hyperspectral. We just started with the hyperspectral. We were able to buy through some other projects, some of the researchers were able to get this hyperspectral lens, which takes wavelengths of light, over 200 wavelengths of light. So by separating out different wavelengths of light, you can see all kinds of things from, moisture stress to potentially leaks and a lot better look at slips and slides. So some of the different things that we're looking at. We started this project in January is when we officially got funded. And so in the spring, we were able to get out at one site before things were kind of locked down. And this is and I apologize that it's hard on the PowerPoint, so the resolution probably won't look as great. But this is a site in West Virginia that we're working with an industry collaborator where we flew. This is roughly half a mile or a little bit more pipeline that we were on. It had been recently reclaimed, and we had flown this with the RGB cameras to collect the ortho photos and also the LiDAR, show a series of these. So you can see the pipeline right away here, and you can kind of see some, if you look closely, you can see some of the BMP structures that are on the pipeline. This is a little bit of a zoom in, and you can see, like, I don't know if you guys can see my cursor, but let me see here. Like this area here, we can see there's the silt fence here, some larger silt fence here. We have some smaller sections here. Each of these are some of the BMPs that are built into like water bars carrying the water down right to these various sections of silt fence. So you can see from that, once we get the ortho photos right at the same time, and these ortho photos are geo-rectified. We have base stations set out on the ground, so we know exactly, where each of these pixels lays on the ground. We then have, some of the digital elevation models. So you can see on the left is raw point cloud from the DEMs, which is pretty cool. You can see here, there's one, oops, let me go back. You can see, this is where the UAV had moved up into the air here. This is the actual, that section of right away. You can see from the cross section, which is really cool, like along this here. You can see those are actually the trees, right? So we're picking up those trees and pretty, I could zoom in on that. You can see those trees in like really incredible detail, right? So pretty cool product. We can take this LiDAR, and then what we do is create a surface with it, which is sort of like, this is a digital elevation model. This is a half-meter digital elevation model. So if we were to zoom in really close to this, each one of these pixels is a half meter on the side, and every one of them has a height associated with it, right? To the nearest, about a half a centimeter. We have. So we know the heights of all of these various pixels, and we pull these together in what's called this digital elevation model, and this is actually a surface. So you can see here are some of those BMP structures that were on that side of the pipeline, right? So from this, it's not really just cool technology. I mean, it is, but if we move to the next stage, right, we can look at, from that digital elevation model. So on the left, we have the ortho photo, and on the right, what we've done, and hopefully you can see this, on the right, we've taken that digital elevation model and done what's called a flow direction, flow accumulation model. So based on the heights of all of those little pixels, they are from the ground in relation to each other, you can predict anywhere on that DEM where if a drop of water hits, where it's going to flow, right? So you can see on this DEM, I've kind of went through and cleaned the data and got to the point where I'm just going to show you this. But you can see, this is right here is kind of like the stream path, right? You can see where that's actually moving, right? Here's another one. So if a drop of water hit here, it's going to come down through here, right? Follow this BMP, and what's it doing here? It's actually going over that BMP. So we kind of have an interesting thing going on here, and you can see in various locations where the water is actually flowing over some of these retention devices, right? Which is cool. And the one that brought up, especially with the industry cooperator they're working at, they were having some problems in this area. And, you know, you could do this on the ground and go out there and continue to walk these to find, and you can see that this area is showing green, so we know we have some water. But if we look at just these preliminary, we can come in and look at this, this actual site, and you can see, right, this is that site, this is the pipeline marker. That pipeline marker is right here. Water is actually flowing over this device, and they've tried to do some work here. It's actually flowing down, and it's actually starting to move outside of this zone and bypassing the next retention device completely and moving downstream, right, or downhill. So what they're going to have here is going to have an area that's going to create a lot of problems with them if they don't get this water over to where they've got all of their treatment structures at this point. You know, if you look at, and I'm going to move back, what we can also do on some of these is look at the actual flow, and you'll notice on this one, you can see as we get more and more networks of this coming in, this one here is red. We can guess the larger, you know, as these rills start to become more of a gully or that side, they're starting to move more water. We can see through those flow accumulation models where more water is moving, and that's one of the things that we'll continue to work on. The idea is to go back onto these sites, and we're going to go back onto this site in the near future and actually work on some of these areas on the ground, and then come back in and refly and see the results. Okay. So again, you can see this site. This one also had a bunch of problems up in this upper end. It was falling off and going across multiple BMPs. Right. So that, in a nutshell, is you know, the ELM program and some of the research that we have going on, and albeit it's you know, kind of at the 30,000 foot mark. But if anybody ever has any questions or ideas or comments or just wants to be involved, you know, at any point, reach out to me and let me know. Love to work with you guys. So that's what I have.
Shawn, I think Natalie had a question.
Okay, let me see if I can pull this up here.
Started to talk here a little bit ago. You
Hey,
want to
Shawn,
unmute?
can you hear me?
Yes.
Okay, I was just asking what UOG was on this slide when you were introducing the
Oh, I'm
research.
sorry. Yeah, I use UOG all the time, unconventional oil and gas. And then we use COG too, conventional. Instead of writing those out all the time.
COG, I'm good with.
Because UOG is kind of like ugly. I guess I didn't think of it that way. Yeah, that's good. Well, if you come up with a better acronym, let me know.
Hey, Shawn, do you guys have any type of fundraisers to help the students?
Yeah, I mean, we do. We have a pretty active. You know, when we got the program started, we had an awesome industry support to get the program started. It wouldn't have been done without the industry. So you know, that side of it we've done really well. As far as student support at this time, what we typically get is we have our student association likes to have you know, different functions and different speakers come on. A lot of times they'll have like pizza during those events. So right now what we do is we ask for industry collaborators to you know, maybe buy 5-6 pizzas for the student group at you know, one of these functions and sponsor that dinner. We're already looking through. We have a number of new students that are taking over the student association this year, and they are you know, excited, and it's kind of a new blood. So I think they're going to try to do some more of these online ones, so to gather more interest. So we'll see how that goes as far as with pizza. But yeah, we're always looking for support, and more than anything, you know, just interaction with folks that are out there working. That's what these students need. So.
I've got a question from Joe. How much national exposure does this program experience, and how do you advertise it?
Joe, I don't advertise whatsoever. So I do not recruit students. I'm afraid to tell you the truth, because at this point we have 2 faculty members. We have 110 students, say, this year, 115, and we have 2 faculty members. We have programs on campus that have 40 students and have 8 faculty members, right, or 10 faculty members, and that's our load as far as advising and that side of it is really difficult. So there hasn't been an enormous commitment from the university to pull on additional faculty full time. So until we get to that point, I'm afraid to. And we do have a lot of guest speakers, like Natalie's come and worked in a bunch of our classes before. We have several adjuncts that are pretty much, they don't get paid very much, but they've been there since the beginning, like Andy Graham with Steptoe and Johnson. He teaches our 2 contracts classes. I have Greg Henthorn teaches our energy operations. We've had a number of people that come in all the time and help us out, so that without them, it'd be tough. So in the future, I'd love to, but at this point, we just can't advertise. So.
Hey, Shawn, it's Ryan. I just saw the AAPL, which a lot of people here are also AAPL members, and they were asking about the bylaw changing regarding accredited programs, one of which I believe would be West Virginia. As far as voting for that and your program, any thoughts, opinions, comments?
As far as keeping our accreditation?
No, the bylaw change, I don't know if you've got that in the email. I believe it was yesterday or today. I believe they wanted to only have universities, students that are in accredited programs, become members and not students in the industry.
Oh, I see. Yeah, I don't think, to tell you the truth, Ryan, I don't see, and the question is, I think what you're saying is and I remember talking about this before, but our students get the students from accredited universities basically get a free membership to APL once as they're a student, and students outside of that could become members of the APL, and they had to pay a small fee, but maybe they're only thinking about allowing accredited students do that. And truthfully, I think they should open it up to everybody that wants to. The more people they touch, the better off they are, one of our, if we were to go out and advertise, people that I have that find us are mainly by word of mouth. And most parents or students for that matter have no idea what a landman is or a land professional, which we try to call, and what they actually do. So the more they can do on that side, the better. And definitely for us, like our huge thing is we need to attract as many. Our diversity, needs to go up, 100-fold. We've done a lot better now. We've gotten up to about 10 or 12% females in our program, and they're doing awesome. And we need to increase our diversity, because we found that, and from the past, a lot of our students that are going out in other areas, they're going into more non-traditional roles, and they're kicking butt and looking for our students. So so that's what we need. In order to build this program, I think Joe asked the question. Our biggest way to grow this program is to get students out there in great positions, and then they come back and are recruiting more students, and that's the best.
Hey, Shawn, so is WVU one of the AAPL accredited programs or not?
Yes. Yep.
Okay.
We were re-accredited 2 years ago. I think I have 2 years left before I have to go up for the re-accreditation again.
Shawn, looking at the drone stuff that you guys are doing, are you guys bringing more of the environmental scientists over to your side to help with those issues with slips and landslides?
Yeah, I mean, the name of the game in the research is collaboration, and there's a number of people that I work with on, regardless of their views on this or that or the other, we work well together and, productive, and we're looking for the right solutions that save time and money. So yeah, my net's wide. I get invited to a lot of these, this research, which is good for us just because of my, connections and contacts. A lot of times, you can always tell like a wildlife student at WVU when they walk down the hallway because their heads like, they don't make eye contact, they don't talk to anybody, so I always kid them about that, but it's the truth. And so a lot of times just, having the ability to go out and work with companies because, the real world, the applied research is where our niche is. Over the last, 10 years, we've been really successful working with, really large corporations down to really small ones and having them fund our research. So when when you're getting money from industry partners to work on research problems that you're doing the right thing. So I think that's it's actually one of the most fun things about what I do.
Does anybody have any questions, additional questions for Shawn? Got everybody in the chat. Well, we'd like to thank you, Shawn, for being our guest speaker this month and expanded my knowledge of what you guys are doing there. It's not just oil and gas, and you're getting into the right-of-way side and the renewables, and as we're all in the business of what's next for everybody, it's good to see that you guys are keeping up with that as well. And last year you had 3 of your students come attend one of our luncheons, and they represented you guys very well.
Great.
So
good. Yeah, if we can ever become, as things slow down, let us know how we can become more involved.
all right, we'd like to thank everybody today. We'll get the video edited down and share it to the YouTube and share the link here shortly. So if nobody else has any other questions, we'd like to thank everybody for attending, and we'll get you some more information about next month. And appreciate everybody's support. Thank you.